So let us look into another problem from the module 3 itself. So here in the first one of the first classes, there we have discussed about how to solve the equation of a 2 degree of freedom. Now let us look into the solution of to find out. Here you can see determine the natural frequency and mode shape of a shear building. Shear building I have explained detail, that is what is shear building. That is a building whose we will considering it as a cantilever, and we are not considering rotation of the beams, only the transverse movement is considered. So here you can see this structure is given. So here m mass is given, m to 2 kg, 1.5 kg, 1 kg. Then k values are directly given. Okay, so I need to find out natural frequency. Natural frequency is omega, and we need to find out the mode shape. Mode shape means phi. This phi values. So here the first of all, I can convert this into this frame into a mathematical or a mechanical model. So here I can write like this. Since it is having no damping, so here the damping value C is equal to 0. So I can generate the equation. How to generate the equation and all we have discussed. So generally or directly you can write the equation. It will be like this. That is, we know that mx double dot plus kx is equal to 0. So what will be m? M will be m1 0 0 0 m2 0 0 m3 into what is x double dot, that will be x1 double dot x like that. Then k value, here you can see how the k matrix is been formed. The k1, that is k that is, here I am having k1 minus k1 minus k1, k1 plus k2 minus k2 minus k2, k2 plus k3. Like this only our matrix will be there into x1 x2 x3, that is equal to 0. Now I can substitute the values. So here I am substituting the values. And one thing you need to understand is that so this is my equation. Okay, now we know that what is a generalized equation, that is by taking the coordinates and all, I will be getting this equation k matrix minus omega square into m matrix, that determinant is equal to 0. So this equation is a simple equation. So here what is k matrix? Here you can see this is the k matrix. So here 600 I am taking common, so I can take a common term, minus omega into this term is equal to 0. So from here I am just I am simplifying only. I am dividing this with the 600. Here also 600, here also 600, 600 I am cancelling. So I will be getting a term like this. Omega square is common. So omega square minus 600. This is taken as a constant lambda. So you can do in your own ways. But the maximum thing is that if I am taking some constant, then our calculation will be easier. We are dealing with matrix. So that is the reason why I have taken 600 as common. So I will be getting this one. So lambda into this one. So this is matrices. So 1 minus lambda. So I just matrix subtraction. Then I am taking the determinant. So that determinant is equal to 0. So here you can see. So what is the value here? Minus lambda minus 1 0. So how can I take the determinant? 1 minus lambda into this term minus 4 plus 1 into minus, that is plus 1 into these terms, minus 1 into 5.2 minus 0 into 0. The next term it is 0. So only 2 terms will be there. So determinant, I hope that you know how to take the determinant. So by simplifying this, I will be getting a equation like this. Okay, that is 3 lambda square minus 16.5 into lambda square, that is lambda cube, minus 16.5 into lambda square plus 20 minus 6 is equal to 0. So here I can substitute the you can solve this equation, and by solving this equation, by taking the common lambda common and all, you can solve the equation. So after solving, I will be getting lambda 1, lambda 2 and lambda 3. Okay, so here you will be getting 3 values. One is by solving this, I will be getting lambda as 3 values. One is 0.351. Next one it is 1.6065, and last one it is 3.5. For here you can take the lowest value as lambda 1. Next is lambda 2. Next is lambda 3. So I found out lambda. Now I need to find out omega. Omega is our main value. So omega, we have assumed that omega square minus by 600 is equal to lambda. So we can substitute lambda 1 and find out what is omega 1. Then similarly omega 2 and similarly omega 3. So these are my natural frequencies. Omega 1, omega 2 and omega 3. These are my natural frequencies I have found out. Now next one is mode shape. So mode shape, here you can see, here I am having equation k minus m into x, that is equal to 0. So here x will be first one, here I am taking. So I can write like this, phi is my vector. So I am just writing x1, x2, x3. This is for the first node. So either you can write like this, 1, 1, 1. Then x2, that is x, next one x1 2, x2 2, x3 3. Next to sorry, this is also 2. Next one it is x1, x2, x3. That is for which node? That is for the third node. So it is one way of representation. Instead of that, you can choose. That is according to you only. That is, here you can choose instead of this. You need not have this same, that is phi is equal to, I can write like this also, x11, x12, x13. Here it will be x21, x22, like that also you can write. But here in this note I am writing like this, x111, like this. So here now I am this equation. Now I am having a technique called as static condensation technique. So what is my aim? I have to find out these values. So that here you can see, static condensation means I am only taking this terms. This first row is not taken. Then you can just understand x1 into this value, x1 into, here you have to careful, x1 into this value minus 1 plus this matrix into x2, x3 is equal to 0. This is known as static condensation technique. That is, here this term, these terms we are not taking. Instead of that I am taking x1 into minus 1 0 plus 3.15 into lambda minus 2, this matrix into x2, x3 is equal to 0. I can write that. Now you can see here I am taking this to the other side. This term is taken to the other side. So here you can see. Now here I need to find out again, here you are having a matrix. So how can I turn it to other side? I will be taking the inverse. So inverse of a matrix, it can be, how can I write? Inverse can be written as adjoint of A divided by determinant of A. Adjoint of A divided by determinant. So you can, I think you need to find out what is adjoint of A divided by determinant of A. So here that is inverse. So now I will be having its assumption. So here I will be assuming what is x1. So I am just assuming x1 is equal to 1. So this term, this one is equal to 1. Now now this is my, and here we are having lambda. Okay, lambda. So we have found out what is lambda, right? Lambda, here we have found out what is lambda 1. First lambda, it is given as 0.351. So I am just substituting it. I am substituting here 0. So I can get a matrix like this. So here now the values are known, so I can find out what is the value. So adjoint of A into determinant of A. So here you can see this is, so this one it is, this was inverse, this was the inverse term. So now I have taken into matrix A inverse equal to adjoint of A divided by determinant of A. So this is a determinant and my 2 points is a adjoint. Now I can just multiply, that is a 2 by 2 matrix into 2 by 2 matrix into 2 by 1 matrix. So what will be my matrix? It will be 2 by 1. So you can write, I will be getting x2, x3 matrix is equal to 0, 6, 8, 4, 0, 3, 0, 1. So what is so my first mode shape will be phi 1 is equal to 1, 0, 6, 4, 8, 1 and 0, 3, 0, 1. Okay, that is the easiest way. Now the second one, same method only, but the only change is instead of lambda, here I am choosing lambda 2 and phi 1 again it is minus 1. So similarly I can find out. I am just taking all same way which we have discussed. I will be getting phi 2. Okay. Now the third one, when it is coming into a third, what will be the change? Lambda will be our lambda 3. Again, 5, I can assume x, all the terms will be assuming phi is equal to 1 only. So likewise, I will be getting phi 3. So my phi matrix will be phi, it will be a combination of phi 1, phi 2 and phi 3. So I can just draw the shape. So this is my mode shape. So this is for the, this is when omega is equal first natural frequency, this is for second natural frequency, and this is for third natural frequency. So likewise I can easily find out the mode shape. So the only thing you need to understand here is that, what is the only thing, that is here we are using some techniques, static condensation technique, and it is being used, but the problem is very simple. Every values will be given, that is in some other problems maybe the k, here directly the k value is given. In the next problem the k value we may need to find out using the equation. Okay, then another thing is that for here here I am substituting lambda in this equation, not omega square. That one you need to understand. So let us look into another problem. So here, determine the natural frequency and mode shape of a given multi degree of freedom where EA is given. Okay, and for all the columns EA is same, 3 meter, 3 meter, 3 meter, everything is same for all the columns. So here what is the change? Here this is M1 is given, M2 is given, M3 is given, but K values are not given. So since it is a fixed point, what will be my value? K is equal to 12 EI by L cube. L here, all L is 3 meters. Therefore, K1, K2, K3 will be same only. So I can find out what is K. I have found out what is K. Now similarly, there is no other changes. We will be finding out the first matrix, K1 plus K2 minus K. So here so K1, K2, K3 is all, everything is given as the same matrix. So I can find out what is K1, K2 minus K. So this term you need to understand, K1. So here this is not there. This is wrong. Here it is K1 minus K2 minus K2, K2 plus K3 minus K3, K3 minus K. So here also I think there was a small here also there is a small thing you need to understand. Here it is K1, here it is minus K2, K2 plus K3, then here minus K2, like that only. Here it is K3 only it will be coming. So since here K values are same, it is no, we didn't have any problem, but the only change is you need to understand what is the equation, that you need to understand. Okay, that is, this is the equation, that is you need to understand, that is this is the equation. So some in the note there is some mistakes are there, but you just follow this one. That is the K matrix will be like K1 plus K2 minus K2 0 minus K2, K2 plus K3 minus K3 0 minus K3, K3. Likewise C values will be like this also. So here for if I am considering for a 2 degree of freedom, the equation was how it this one, it was like this, K1 plus K2 minus K2 minus K2, K2, like that. So here also the term which we are discussing in this equation also, that is a, just a minute. So here okay, so here we are having a small change. Here it is not like this, it is K1 plus K2 minus K2 minus K2, this is K2 plus K3 minus K3 0 K3, this is K2 plus K3. Okay, so sorry, here it will be only K3 will be coming. Okay, so this is some mistake is there, so you need to understand that. So here, so that is the reason why it is being written here. So K matrix, just understand the matrix. If you are having any doubts, you can derive this equation, then it will be easier, but no, anyway no need. So here this equation here you can see, that is K1 plus K2 minus K2 minus K2, and what will be the value here? This is the correct one only, K1 plus K2 minus K2, here it is minus K2, K2 plus K3 minus K3 minus K3, K3. Okay, so now this is the general equation we are having. So same way we will be taking. So here you can see in the last case we are taken omega square by 600 as common. Here we are taking another term, because what is the highest common you can take, that you can just take it and substitute. Now by substituting that, first of all we will be getting an equation, a higher degree equation. Now you can find out the solution. So you will be getting three values. The lowest value will be lambda 1, then next highest will be lambda 2 and lambda 3. Now by substituting this lambda 1 in this equation, we can find out the natural frequencies, omega 1, omega 2 and omega 3. So that will be our natural frequencies. Then now after finding out the natural frequencies, the next thing we need to do is the mode shape. So in order to find out the mode shape, here you can see minus 2 lambda, and this is by using which equation, which technique? Static condensation technique. The first row I can eliminate and I can take the next two rows. So here what is static condensation? That is, here this can be written as this term minus 1 0 into x1 plus x11 plus this matrix into x2 x3 is equal to 0. Now this is having, now I am substituting x11 is equal to 1, assuming lambda 1 is equal to 0.055. So similarly, I am not explaining this too much, that is, similarly I can find out lambda 1, lambda 2, likewise substituting and finding out, I can find phi 1, phi 2, phi 3. So I will be getting phi 1, phi 2 and phi 3, and these will be my figures. This is for the first node, this is for the second node and third. So this represents, that is, if I am having a building and the building is subjected to a natural frequency. That is, natural frequency means it will be having some vibration, and when that vibration is equal to the first natural frequency, then what will happen? It will be vibrating. The deflection will be like this. The first floor will be moving by 1 meter. Second floor will be moving by 1 meter or 1 millimeter, it depends. Then a second floor it will be 1.171. That is a meaning. So but when it is omega 2, one is moving towards the left, other to the right. Likewise, it will be having a zigzag movement. Or that is a way in which you will be getting an idea when the vibration is taking place, how the movement of a structure is. That is a basic thing you need to understand. Okay. So in another problem you can see here, the same problem is given, but it is a 2 degree of freedom only. You can see here, but k is given, k1, k2, 2k2. Determine the natural frequency and a steady state response. Steady state response is because here we are having a force. That is, a new change is coming. Here you are having a force. What is a force? F cos omega t. A cos omega t force is also given. So how we can solve that? So you just need to understand that mostly the questions will be like from the free vibration, but in some cases the force vibration can also be asked. So first one, it is we need to formulate the equation. So for that I am here you can see how I am writing the degree of for the free body diagram. So here for the free body diagram, first free body diagram is drawn here. M1 x double dot plus kx minus f is also there. Then here this is a second free body diagram. So here I can two equations I will be getting. That equations I am converting it into a matrix form. So m0 0 to m2 into x1. The k value here I can see we have found out. So this will be my matrix equation. That is the first thing. Now I am having this characteristic equation is k minus omega square into m is equal to 0. Now in this I am just substituting the values of k and m. So I can take the determinant. So here I am just dividing it by k. So in different methods I can solve this. I am just making it simple. So I will be getting an equation like this: 2 minus 3 minus 3 minus omega square m by k into 1 0 0 0 2 is equal to 0. Now I am taking this term as omega square omega n square m by k is equal to lambda. So here 2 minus 1 3 minus lambda into 1 0 0 0 2. The determinant is equal to 0. Now I can taking the determinant. I'll be getting an equation. This is my equation. It's a second degree equation. Why it is second degree? Here the degree of freedom is only 2. Therefore, I will be getting two values. One is 1 and other is 2.5. So this one will be lambda 1 and this one will be lambda 2. Now directly I have got what is lambda 1. So I can how can write? I need to find out omega 1 and omega 2. So omega 1 is equal to root of k by m. So I can just substitute and find out what is omega 1 and omega 2. Now again the same way we can find out the mode shape. So here no static condensation techniques are needed. So here I will be getting equation. I will be assuming x1 is equal to 1, then x2 is equal to 1 or some other value. So here these are my values. When that is phi matrix, I can write it. Phi matrix will be like this. What is the matrix? 1 1 1 0.1 by just substitution. Okay. Now the change in this question is we need to find out the steady state response, that is due to the forced vibration. So here this is my equation, that is equation which I got from here, that is minus m omega square, that is this equation. Before taking this is my, here you can see this one. Okay, so here minus m1 omega square plus k1 plus k2 minus k2 k2 into AB into F is equal to 0, force vibration. Now here I can find what is AB. AB will be F into minus m omega square. Just taking the term equation, I can, this is one equation, right? So this is one equation. Next second one is this one, B is equal to, okay, I can A and B. Now I am just, this is my first equation, I am substituting. So I can find out what is A. So here I can just form the first equation. This is my second equation, and so here k a instead of A I can write 3k minus 2m omega square by k into B. Substitute, that can be substituted in the first equation, and I will be getting, I can get the value of B. Similarly, I can find out what is the value of A. Now x is equal to A cos omega t. So here A we have found out. So this is my steady state response. So just read the what is written, understand the note. So it will be, you will be able to understand it. Okay. So the main thing you need to do, understand what we have discussed in this equation, in this video is, so in this video is to how to find out the phi matrix of a 3 degree of freedom system, that is a MDOF system only, and a small problem about an FDOF system. Okay, that is with a forced vibration analysis. Okay, so that's all for this video. Thank you.